Hello Kutukudiyas, today we are going to study atoms and molecules, and this chapter must have seemed very tough to you because you haven't watched the master's gunshot lecture yet. Let's start atoms and molecules. First of all, we will start the chapter with some brief history of what is this atom. We have to read atoms and molecules chapter. ये atom होता क्या है? What is this concept of atom? Who searched atom and who discovered the atom? For you and even for me, it's a moment of pride that the discovery of atom is done in our own country, India. And today, this has been accepted by the whole world. Our saints, sages discovered a lot of things, and one of them is most important discovery is of atom. 500 BC means 1,000 years back from today, we had a saint named Maharishi Kannad. We can call them a philosopher too. He said that if we consider a matter, for example, this pen or this smart board, table or TV or yourself, if I divide any matter by breaking into small pieces, if I keep dividing any matter smaller and smaller parts, so by breaking it again and again and again, making it smaller, it will get such a point where I will get so small particle that I can't break any further. This matter, he called this matter Padarth. It's called Padarth at our place. He said, if I keep breaking and keep this matter and make it smaller, then in the last, I will get such a particle which will be indivisible. Indivisible means something we cannot break or divide. And he named this particle as Parmanu. Bhai, what do we call this atom in English? Parmanu. Approximately 100 years after that, similar discovery is done by Greek in Greece. Then there was no such mobile or internet, so similar discoveries used to happen in different parts of the world. It's not even communicate in between them. So there was some Greek philosopher in Greece, one is Democritus and one his teacher Lysippus. They also said the same thing, that if we keep breaking the matter and keep dividing into smaller parts, so we will get as such a small particle that would be indivisible, which we won't be able to divide anymore. And indivisible only means atom. The name they gave the name atomos, A-T-O-M-O-S, atomos. But NCERT call it atom, so that's why I have written atom here. They named it atomos. Atomos means something that we cannot divide any further. So the concept of atom arrives from here. But beta, this was the time where there was no labs, we don't have any experiments, not much of information was there. So this concept is roughly okay. This concept will get better with the passage of time. So if I talk about today's time, so beta, what is the concept of atom today? It's a little modified. And today's time, it is said that the smallest fundamental particle, fundamental means something from which the whole matter is made up of. The smallest fundamental particle of matter is atom. The smallest particle of the matter is atom, which may or may not exist independently. Means, beta, like how you live, single, lonely, but that's not your choice, that's your compulsion. How are some people? They are committed, live together. So this is how the case of atom. Some atom live alone and some lives in group. So which may or may not exist independently. There is a possibility they can live alone or possibly they cannot live alone, lives in group. But always take part in a chemical reaction. Wherever there is a chemical reaction going on, atom will approach that I want to participate. Whenever there is an annual function in school, we approach that we will run also, we will participate. Atom is similar. If it sees a chemical reaction, it participates for sure. The smallest fundamental particle of matter which may or may not exist independently, it's possible it live alone, it's possible it won't live alone. But always take part in a chemical reaction. It will always participate in a chemical reaction. The discovery of atom that we read in the start, whether it's Maharishi Kannad or Greece philosopher, everyone said that atom cannot be divided. It's the smallest particle. It's indivisible. It cannot be broken any further. But today's modern science states that atom can be broken by, but it cannot be broken by any chemical reaction, which means that if I pour acid on this pen, so pouring of acid won't break its atom. If I pour phenol over there, pour any base, any chemical, no chemical reaction, chemical method can break the atom. But there is one way through which we can break atom. and we get to know that it's a smaller particle than atom. We have to learn it in the next chapter. You must have heard it. Electron, proton, neutron. Have you heard about it? What are these? These are all atomic particles. There is a particle of inside the atoms also. But for now, we will agree that by chemical method, by any chemical method, we cannot break atoms by any normal and day-to-day life. If you at your home, you cannot break atom. Nuclear reaction is needed for this beta. We will study in the next chapter a little bit. Okay, so for now, an atom cannot be divided by chemical reaction on method, chemical reaction, chemical method, or day-to-day life, physical method. If you think of breaking atom with your hand, you cannot break it. Atom beta is so small that when you bring microscope, and even then you cannot see, even then you can't see it. If you bring very strong, very powerful microscope, even then you will not be able to see it. We can only see the layers of atoms these days with some special equipments, but with microscope, atom is so small we can't see it. Atoms are so small that we cannot even see them even under high power microscopes. Now, bhai, atoms are so small, but these days such equipments are there. Science has come so far. So shape of atom is almost confirmed. Atom is considered to be almost spherical. Almost. How is it? Spherical. Beta, should I tell you the truth? It's very difficult to say anything about the atom with guarantee. Why? Because discoveries are continued. Concepts are getting better in every 20 and 25 years. But current concept says that the smallest fundamental particle of the world is by which matter is made of, which can exist alone and may doesn't remain alone, but it always participate in chemical reaction. We call that atom. Can we further break atom? Is atom divisible? What will be your answer? Yes, but not with chemical reaction. Yes, we can break it in atom, electron, proton, neutron, and more particles are there in the atom. But we cannot break atom by any chemical reaction. Like you have shown here. Look, here is a gold displaced. What is gold made of? It's made of small particles of atom of gold. Alright, note, atom can be divided further by other methods. So we will dive into atom also in the next chapter. The chapter we will come next. Moving forward, bhai. Now, bhai, we will talk about how small is atom. Very small. How small, beta? It's so small that you have a nail. A nail of iron. If you take a nail of iron, that's so much small nail. There are 10 to the power 23 atoms in it. 10 to the power, say it's iron nail. Inside it, how many small atoms of iron are there? 10 to the power 23 means 1 0 0 0 0 0 0 0 0 0 0 0 0. How many times? 23 times. Millions, billions. Crores atoms are there in a small nail. This is how much small it is, beta. Atom is so much small. Now comes, if atom is so small, then how we measure it? This we understood. How is atom? It's spherical. Almost it's spherical. If something is spherical, then we have some radius of it. So how many meters in the radius of an atom? How many centimeters? Now, beta, we cannot measure it in the meters or centimeters. If it is very small, even it cannot be measured in millimeters. It cannot be in decimeters. So a very small unit was introduced to measure the size of atom, which we call nanometer. Nanocar, you heard? It's a small car. Nano means small. So nanometer was a unit to introduce by which we can measure the size of the atom. So small that we need a unit. Nanometer. What is nanometer? Beta, 1 nanometer is equals to 10 to the power minus 9 meter. 10 to the power minus 9 means 1 nanometer, means 1 nanometer, how much is it? 1 upon 1 0 0 0 0 0 0 0. How many times? 9 times. 1 upon 1 0 0 0 0, how many times? 9 times. 1 meters 0 0 0 0 0 means how much it becomes? 1 nanometer is how much? 0.00003456789 meter. 0.000000000, 1 meter. This much small is the atom's radius. Like you study the radius of hydrogen in class 11, the ratio of beta hydrogen is hydrogen atom's radius, that is 5.3 nanometer, means 0.0000000. Here is 5 and 3 meters. This much small is the size of atom. If I compare this, NCERT also gives an example. If I compare this, so the atom of hydrogen, they have told almost 10 to the power minus 10 meter. Compare this with the size of an ant. The size of an ant is 10 to the power minus 3 meter. Compared to this beta, how much small is this? How much small it is? Almost 1 crore times small. You see an ant, we are able to see an ant. Atom is 1 crore times small particle, that is. It's very small particle. Is atom divisible? Yes, it's divisible. Most smaller particles are hidden within it. This is what atom is. In which unit atom size is measured? Do remember, in which we do nanometer. 1 nanometer is 10 to the power minus 9 meter. Clear? Let's move further. Next thing is what this atom is. The whole world is made up of this. I am also made up of atom. You're also made up of atom. She is also made of. Everything is made of atom. So how does this atom combine together? Is there any rules and regulations, or this atom just anyway combines, and after combining they become this pen, it becomes me, it becomes you? Some rules and regulations must be there. Universe has made these rules and regulations. We are just trying to understand this. We have never made this. We cannot say that we made the laws. Laws were already existing. We are just discovering it. We are thinking this might be happening. So there came a very great scientist, Anthony L. Lavoisier. What concept did Anthony L. Lavoisier have? Laws of chemical combination. Laws of chemical combination. The laws of universe that gave birth to chemistry was given by him, by Lavoisier. He just gave the 5 laws which covers the whole of the chemistry. But we have to study 2 laws from that in our syllabus. These are the laws which are going to decide all the rules of chemistry and laws of chemistry. They tells how atoms combine, how is the combination formed, how does chemical reaction happen. He told everything. We have to study these 2 laws from that 5 laws. First is law of conservation of mass. This you must have already heard it. Second law is law of constant proportion. Now whether say it constant or say it definite, both are same. Law of constant proportion or law of definite proportion. Who gave this? Anthony L. Lavoisier. He gave these 2 laws. Now we have to look at the 2 laws. First we read the easy one, law of conservation of mass. Everybody knows this. Mass can neither be created nor be destroyed. It can be changed from one form to another form. Everyone knows it. Should I tell the truth? Mass can be created. Mass can be destroyed. You see this equation in my hand. This is the mass energy equivalence of Einstein. I have written it reversed in my hand. Do comment and tell me why have I written reversed. If we talk about today's time beta, mass can be created. Mass can be destroyed. Science has gone too far. But if we read about the basic, if we talk about the Anthony L. Lavoisier, our day-to-day life, if we talk about common lives, we talk about home, we talk about office and school, their mass can neither be created nor be destroyed. If there is any chemical reaction happening, then there no new mass is produced. Older mass doesn't get destroyed. Whatever chemical reaction you do, mass doesn't change in that. For example, here I have taken the chemical reaction between hydrogen and oxygen. I am taking the chemical reaction between hydrogen gas and oxygen gas. This reaction doesn't happen. This normally too much conditions were applied, then it happens. Hydrogen and oxygen were combined. They form water. Water. It's formed water. It's formed. We saw if we have 4 grams of hydrogen and 32 grams of oxygen, then I said how much water is formed. I see 36 grams of water is formed. 36. Means if I add this side, how much mass is there? 4 and 32, 36. And this side also 36. Means mass on the left side on the side is equal to the mass of right hand side. The amount of hydrogen and oxygen will combine. The same amount of water will be formed. No new mass will be created. No new mass will be disappeared. It cannot be happen in common life. In normal reaction, the mass gets reduced. Mass gets increased. It happens in some special reactions by. So what does this law tells us? This law tells us mass can neither be created nor destroyed in a chemical reaction. Mass can neither be created nor destroyed in a chemical reaction. If this side 4 plus 32, 36 grams, then this side also 36. Neither will be 37, neither will be 35. Means mass in the LHS is equal to the mass of RHS. Now this chemical reaction, whatever in this side will happen, we call this reactant because they are reacting. And whatever is formed this side, we call this product, which is the finally formed. So what does this law say? That whatever mass and of this reactants, of all the reactants, the same mass will be of all the products. All means it may happen that more things are produced. If we see different chemical reactions, many more things are there. So whatever total mass will be of the reactants, the same total mass will be of products. total mass of reactants is equals to total mass of products in what? In a chemical reaction. This is the first law, law of conservation of mass. Let's look at some questions here. There is an activity 3.1 given from NCERT. This activity proves the same law. What is it by? First, we took a box in this, a flask. We took a test tube inside it. We put one chemical in the flask and put another chemical in the test tube. Solution Y in flask. Y, what is in Y? What did we take in the flask? We took Y chemical, and in tube we take X chemical in the tube. That can be any two chemicals. We took any two chemicals. We took Y here, we took X here. I carefully tied this test tube with a string and hung it like this, so that the test tube tilt like this. This one solution of X, the X chemical inside it doesn't fall from it. Reaction doesn't start here. So X chemical is there in the test tube and Y chemical is in the flask, and this test tube is hung tight with a string so that it doesn't spill into it. Now at starting, I did weight this whole setup. How much is the weight? How much weight is combining after X and Y? So first of all, I took solution Y in the flask, X in the test tube. Suspend the test tube in the flask with the help of a thread. I hung it by a thread so it doesn't spill out of it. Weighed the whole arrangement carefully. Then what did I do of this? I did the whole arrangement. I weighted the whole arrangement. I weighted. Now X and Y are separate. They are not mixed. I weighted the whole arrangement. Let us say the weight is 100 grams. Suppose what is the weight? 100 grams. Then I spilled the chemical X from this test tube like this, and I loosened the thread and loosened the thread. So where did X went? Into Y. XY went into it. Chemical reaction started. Now some products were produced. Let us say a new product is formed, XY. Anything can be formed. Some product XY is formed. Both are mixed. Then I said, now bhai, chemical reaction is done. Product is formed. Now I will measure this again. I measured it again, and now what is the weight come of the product? Because X and Y are mixed, I took the weight of the product. What did I do? Make solution of X and Y by tilting the test tube. By tilting the test tube. Weight the arrangement again. I weighted it again. How much weight comes in the second time? Second time also, how much the weight did come? 100 gram. Means what the weight was the reactants, the same weight is of the product. What are the observation? Weight before mixing is equals to weight after mixing. What conclusion did we get from this? This we saw the weight is same. What is the conclusion from this? Conclusion is that the law of conservation of mass is valid in this chemical reaction. This proves the law of conservation of mass. Now it comes what may be X, what may be Y. It may be two chemicals of the world which reacts with each other. Any two chemicals of the world which reacts together. For example, X may be copper sulfate, it may be barium chloride, it may be lead nitrate. Y may be sodium carbonate, it may be sodium sulfate, it may be sodium chloride. So X and Y are different chemicals that react with each other. Let's see a question. NCERT's question. In a reaction, 5.3 gram of sodium carbonate. This is sodium carbonate. How much is it? 5.3 grams. So I write it here. 5.3 gram of sodium carbonate reacted with 6 gram of acetic acid. To which does it react? To 6 gram of acetic acid. The products were 2.2 gram of carbon dioxide. How much carbon dioxide released? 2.2 gram of carbon dioxide. 0.9 gram of water. What else was formed? 0.9 gram of water is formed. And 8.2 gram of sodium acetate. What is formed? 8.2 gram of sodium acetate is formed. Show that these observations are in agreement with the law of conservation of mass. Prove that law of conservation of mass is valid. So bhai, let's check what? Total mass of reactant. Total mass of reactant. How much is the total mass of reactant? 5.3 plus 6. How much is it? 5, 6, 11. 11.3 gram. And let's calculate total mass of product. I am traveling now. There are lots of works in our company, isn't it? So that's why I'm in a different studio. That's why I have a pen in my hand today. I didn't get that and a stylus. Mass of product. What are the products? This. So 8.2 plus 2.2 plus 0.9. How much is it? 9 to 11 to 13. 1 in hands. 2 and 1, 3, 8, 11.3 grams. Say bhai, it's equal. total mass of reactants is equals to total mass of product. Hence, what did we say? Proved that bhai, it's correct. Total mass of reactant is equal to the total mass of product. So this is proved. Let's see the next question. If the law of conservation of mass holds true, if the law of conservation of mass is true, which is obvious, how much sodium chloride will react with 34 gram of silver nitrate? This is silver nitrate. How much is the silver nitrate? 34 grams of silver nitrate to produce 17 gram of sodium nitrate. How much sodium nitrate is formed? 17 gram of sodium nitrate and 28.7 gram of silver chloride. This is the silver chloride. How much is it? 28.7 gram of silver chloride. What is the question? How much sodium chloride will react? How much is the sodium chloride? It is not known. Should it be X? Suppose how much is the sodium chloride? It is X. It is carried to CX. One thing she left us and the sadness come. Let's come back. Now, bhai, if law of conservation of mass holds true, then total mass of reactant is equals to total mass of product. So I will write bhai total total mass of reactant is equals to total mass of product. All right. Come bhai, let's put the values. How much is this side? 430 plus how much? X. What is the product? 28.7 plus 17. Say bhai, is it doable? Solve it and do comment the answer. You will do it. Value of X is to be calculated. So you calculate it from here. It will be 11.7 gram after calculation. Option B is the correct answer. Say it's easy question. Very easy, sir. Let's go bhai, move forward. Next law is law of constant proportion. This beta you will need to understand a little new. It is called law of definite proportion. What does this law states? That any chemical compound in this world, for example, I take water. If I take water anywhere in this world, whether take it from river, whether I take it rainwater, whether I take tap water, whether I take water from well, wherever from the world I take, and I purify it, then it is the condition. It must be pure compound. Then I will see inside water, what are all? Hydrogen and oxygen is there. So the hydrogen and oxygen that are in the water, that will be the same ratio of mass, no matter I take it from where and how much. Whether I have a water bottle, whether I have a water glass, or I have a water drop, it all have, what do I find? I will find the same element everywhere. Which one? Hydrogen and oxygen. And nothing is to be found if it's pure water. No matter from where I bring the water and how much I bring the water, every time what will I find in? Hydrogen and oxygen. And every time the ratio of hydrogen and oxygen, that will be the same. This is the law that states the same thing. What does it say? A pure chemical compound always contains the same elements in the same proportion by mass, regardless of the amount of compound and the source of the compound. If there is a pure chemical compound, then always contains the same elements. Its elements will never change. It is not like that if you take a glass of water at home, then it has hydrogen and oxygen. And if you take the river water and purify it, then you will find carbon and sulfur and all that. If you purify it, then will not be found. Only hydrogen will be found. Anywhere in this world there is water, there will always be the same element. Which one? Hydrogen and oxygen. And in the same proportion by mass. And there is ratio of mass, there will also be the same. Regardless of the amount, how much water is bought and the source of the compound. That is from which source is bought. Let's see with an example of water. So I said I have 36 gram of pure water. What is made from? It's made from hydrogen and oxygen. All right. So I saw in 36 gram of pure water, there was 4 gram of hydrogen, 32 gram of oxygen is there. I checked all these by, I bought the water, I measured it. Then whatever game played in the lab, that's data is found. Then I said, if I saw 18 gram of pure water, then there was 2 gram of hydrogen and 16 gram of oxygen. When I saw 9 kg purified water, big by very big container we have bought, 9 kg pure water. I said it has 1 kg hydrogen and 8 kg oxygen. Then your mass is changing, but what have they said? In the same proportion by mass. If I calculate ratio of hydrogen is to oxygen, the first one, 4 is to 32. 4 is to 32. It is eliminating with 8. Obviously, yes. 4 ones are, sorry, it's eliminating with 4. 4 ones are 4. 4 8s are 32. What is the ratio? 1 is to 8. Look here, what is it? 2 gram is to 16 gram. Ratio of hydrogen is to oxygen. 8's eliminating with 2. Yes, 2 ones are 2. 2 8s are 16. 1 is to 8. Look here, it's already 1 is to 8. Means hydrogen and oxygen are present in same proportion by mass. No matter how much water we take, wherever we take the pure water from, the same is what? Law of constant proportion and law of definite proportion. These two laws were given in by Anthony L. Lavoisier. So pure water always contain hydrogen and oxygen in the ratio of 1 is to 8 by mass. You must write by mass because hydrogen and oxygen are gases. So by volume, it's also a ratio. So by mass is must. This may be obtained from river water, rain water, or groundwater. Whether you take it from river, whether you take it from ground, whether you take it from rain, or but purified for sure. Bhai, otherwise there will be impurities. The correct ratio will not be obtained. All right. Let's read the same thing with the case of carbon dioxide. I will explain you in the exact free flow. The formula of carbon dioxide is CO2. So beta, what is it made from? It is made from carbon and oxygen. Suppose I take 44 gram of carbon dioxide. 44 gram of carbon dioxide. I see it has 12 gram of carbon and it has 32 gram of oxygen in it. Suppose I take 22 gram of carbon dioxide. Then I see it has 6 gram of carbon and 16 gram of oxygen. Should we see the ratio? Come, let's see the ratio. Every time this made from carbon and oxygen only, let's see the ratio. What is it? 12 is to 32. So 12 is to 32. It will be eliminated by 4. How much will it become? 4 3s are 12, 4 8s are 32. 3 is to 8. What is here? 6 is to 16. 4 will be eliminated. Sorry. 2 will be eliminated. 2 3s are 6. 2 8s are 16. 3 is to 8. Every time, beta, there will be 3 is to 8. Now come, let's do an answer of the question. If I have 11 gram of carbon dioxide, how much? 11 gram of carbon dioxide, then how much carbon we have to give and how much of same will be there? Come, let's tell me. Bhai, look here, I halved it. So here is also half, this is also half. Halved it furthermore, then it also got halved. How much is it become? 3 gram. And this will also be 8 gram. And see, the ratio is also the same. What is it? 3 is to 8. Does this happen only in water or carbon dioxide? No, beta. If you pick any pure compound of the world, it will always be made of the same elements and it will be the same proportion by mass. Always. This proportion by mass is definite, fixed and constant. We can tell of any compound in the world that the elements that are present, that by which ratio they are. Now the matter of amount will be increasing its amount. The elements will never change there. And the proportion by mass will never change. One thing you have to comment here, everyone will comment, if I have 88 grams of carbon dioxide, then how much carbon will be there and how much oxygen will be there and what will be the ratio? Everyone comment bhai in the answer. I will see that you understood or not. All right, let's do the question. Come, question. Hydrogen and oxygen combined in the ratio of 1 is to 8. This we already know. We have studied this, that this hydrogen and this oxygen, in which ratio they are combined? 1 is to 8. Very good. By mass to form water, they make water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? It says us that I have hydrogen gas and I have gas of oxygen. And combining together, what they form? Water. They form water. What are they saying? What mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas? If I have 3 gram of hydrogen gas, then how much oxygen gas is needed so that completely react with this? Think, yaar. If hydrogen has been 1, then how much will be the oxygen? 8. If hydrogen is 2, then how much will be oxygen? 16. If hydrogen is 3, then how much will be the oxygen? 20. Are yaar, unitary method yaar. Like this, 1 gram of hydrogen reacts with 8 gram of oxygen. It is right. So 3 gram hydrogen will react with 8 divided by 1 multiplied by 3. How much does it become? 24 gram of oxygen. Unitary method. That if 1 gram of hydrogen combines with 8 gram of oxygen, then 3 gram of hydrogen will do with whom? 8 upon 1 multiplied by 3, 24 gram. So beta, how much is the oxygen should be? 24 gram. Does the option have 24? It is there. Tell me, do you understand? Very good. Let me do one more question with you. Come, let me ask you that suppose carbon and oxygen combines to form carbon dioxide. All right. Let's suppose. Actually, one more thing produced in the reaction, but I will apply some conditions here, and I will do kuchu. I will apply some conditions like this. This will happen. Don't take tension. I have taken it from master. I have taken care of this. Now you understand this. Now you understand. I say carbon and oxygen always combined in the ratio of 3:, how much was it? 3:8. What is it? 3:8. Carbon 12, oxygen 32. 4 3s are 12, 4 8s are 3:8. Now I ask you, what mass of carbon will react with, let us say, will react with 4 grams of oxygen? Come on, comment in the answer to this. Can you do it? Pause, comment. What mass of carbon will react with 4 grams of oxygen? How do we do it, sir? How do we do it? Listen, bhai, listen. Oxygen is 8, so carbon is 3. That means 8 gram of oxygen is combining with what? 3 grams of carbon. This is given. This is given in the exam. Don't take tension. Don't memorize. Acha. 8 gram of oxygen combined with what? 3 gram of carbon. I asked for 4 gram of oxygen. What did I ask? 4 gram of oxygen. So, beta, 3 divided by 8 multiplied by 4. 3 divided by 8 multiplied by 4. So 4 2s are 8, 3 by 2, 1.5 gram of carbon. Tell me, will it answer? 3 divided by 8 multiplied by 4 equals to 1.5. So what will be the answer? 1.5. Is this what you have commented? Congratulations. Well done, bhai. Actually, it was very easy, beta. If 8 is combining with 3, 8 had to be half and make it 4. And then this will be also be half and it will come 1.5. You could find it this way. Half that, you also have. You understood this law? Law of definite proportion. Here is a good question from NCERT that students generally get wrong. Pause and comment, then I will explain. When 3 gram of carbon is burned in 8 gram of oxygen, I have carbon and I have oxygen. What is it saying? That 3 gram of carbon burns with 8 gram of oxygen, 11 gram of carbon dioxide. The product being formed is what? Carbon dioxide is being formed. What is the data given? 3 gram carbon burned with 8 gram oxygen. What is it being from? 11 gram carbon dioxide. First tell me, is it right or wrong? How will you know? Law of conservation of mass. 3 plus 8, 11. 11 on this side. Yes, bhai. It's equals to same. Mass of reactants, total mass of reactants, total mass of product is equal. Acha. Listen further. What mass of carbon dioxide will be formed when 3 gram of carbon is burned in 50 gram of oxygen? They are asking how much mass of carbon dioxide will be formed. What mass of, where did it go? This. What mass of carbon dioxide will be formed when 3 gram of carbon dioxide is burned in 50 gram of oxygen? Now tell me, should we apply the law of conservation of mass? How much is the mass of reaction will be? 3 plus 50, 53. So how much will be the mass of product? 3 plus 5. How much will it become? 53. Law of conservation of mass. So which would be the correct option? Option A. Tell me, did you understand? It is wrong. Sir, then why it is wrong? Everything is, sir. I will explain you. Listen carefully, bhai, listen carefully. You were given 50 gram of oxygen. That doesn't mean that 50 gram of oxygen will necessarily react with carbon. Are bhai, 3 gram of carbon, it's only 8 gram of oxygen. That means out of this, how much this is 3 gram? How much will be take off from 50? It will only take 8 gram and react with that. The remaining 42 gram of oxygen will not go undergo reaction. Law of constant proportion. This is the intelligence. What bhai? It says 3 gram of a carbon reacts with 8 gram of oxygen only. Law of constant proportion, definite proportion. More oxygen than this will not react with 3 gram of carbon. It won't join it. Then it says 50 gram of oxygen with 3 grams of carbon. Oxygen is spread out here, right? Now small piece of carbon would react with all the oxygen. How much oxygen does it need? It needs only 8 gram. It will only react with 8 gram. How much is left over? 42 gram of oxygen is left. The reaction will not happen with that. 3 and 8. What will the answer here? 11 gram again. Which option is correct? Option B, 11 gram. Again 11 gram, because 3 gram of carbon will react with only 8 grams. Things are going wrong by applying the law of conservation of mass, but the law is not wrong. Your thinking is wrong. Your thinking is bad. That you give all the oxygen to it, it doesn't need it. Bhai, 3 gram of carbon is just saying we will not react with this much oxygen. Give us less. How much? We need only 8. Give 8. These two reacted. The total product is 11 grams and 53 grams. Which law of chemical combination govern your answer? Bhai, tell me in the comments, which law is this? Law of constant proportion, law of definite proportion. Should I write it? Which law is this? Law of constant or definite, both are correct, proportion. You've got fun? Yes, master. It was fun. Mauj ho bhai. Come on, bhai. Let's move forward. So, bhai, you have done the numericals. Look at both laws well once. Who knows, they might have asked in the exam. So, laws of chemical combination. There are two laws first. Very simple. Law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction. There are some reactions where mass is created and be destroyed. But mass can neither be created nor destroyed in a chemical reaction. Total mass of reactants is equals to total mass of products. Come on, bhai, I have remembered this. Next is law of constant proportions or law of definite proportion. Look carefully at its definition. A pure chemical compound always contains the same elements in the same proportion by mass, regardless of the amount of the compound and the source of the compound. Okay. So what is it saying? A pure chemical compound always contains the same elements in the same proportion by mass, regardless of the amount of compound and the source of compound. With whose example did we study? That of water. That if pure water, it will always be formed only in the same elements of hydrogen and oxygen in the same proportion by mass, 1:8 proportion by mass, regardless of the amount of water, whether it is palm full of water or a pot full of water, and the source of water, wherever the water comes from, but it should be pure. Clear? So memorize these both laws well once. Bhai, until now we have studied the basic things about the atom. The discovery of atom, who did it? Maharshi Kannar Sahab did it. He explained that there are Parmanu. Then after that, the discovery also happened in Greece. Democritus and his guru Lysippicus also give the same thing. Indivisible particle is atom. But for the first time in the world, if anyone properly gave a theory of atom, properly created some points, explained the atom in a structured way, it is John Dalton Sahab. The first universally accepted, everyone accepted that theory. Whose was it? John Dalton's. He stated some assumptions. He stated some points with whom, and why did he become so famous? Because with his theory, we could explain the two laws of Lavoisier, the laws of chemical combination, the law of conservation of mass, the laws of constant proportion. So John Dalton's atomic theory. According to Dalton's atomic theory, matter is made of tiny indivisible particles called atom. We already know this, okay? His atomic theory was based on the law of chemical combination. Dalton's atomic theory provided an explanation for the law of conservation of mass and law of definite proportion. Now, beta, Dalton Sahab stated some points about the atom. These were not completely proven. We call such points in physics or science postulate. Postulates mean that they are assumptions, that this are Saab's assumptions. Look, these are the era of John Dalton Saab belongs to, even that era where no such dangerous labs or such excellent equipments that everything could be proven. But he stated some assumptions which we have to study, and remember, there are many assumptions that we have some in our syllabus, we have to remember those. So what came? Postulates or assumptions of Dalton's atomic theory. Why was this theory so accepted? Why this was so popular? Because it explains the laws of conservation of mass and law of constant proportion. Explain. So let's see what are the assumptions. All matter is made of very tiny particles called atom, which participate in a chemical reaction. Bhai, this definition is still correct. That all matter is made of what? Small particles that are called atoms, which we may remain alone, which may live in a group, but always participates in a chemical reaction. Then he said atoms are indivisible particles. We cannot divide the atoms. In today's time, this statement is not completely correct. We can divide the atom and electrons, protons, neutrons are found inside the atom, which cannot be created or destroyed in a chemical reaction. This is absolutely correct. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Suppose I started a chemical reaction and I had 1 crore atom here. Then how many atom will I have in a product 2? 1 crore atom. The number of atoms will not change. What we understood from this, that the mass of atoms here will be the same as the mass of atoms here. That means, what was this assumption explaining? Law of conservation of mass. Law of conservation of mass was explained by this postulate or by this assumption. By obviously, suppose I'm here, you are here, your father is here, and when the product came, I'm still here, you are here, your father is here. Earlier, you and your father were together, now I and your father are together. You got scolded. But total mass of me and your father is here, and here too it's me, father and you. So total mass will remain same on both sides. So what we're explaining, it's law of conservation of mass. Next, atoms of a given element are identical in mass and chemical properties. Understand its meaning. Let's assume I have iron. So the different atoms of iron, bhai, what could be the iron made of? It would be made of lots of atoms. Anything beta, be it iron, carbon, hydrogen, everything's made of what? Small atoms. They are saying that the atom of all elements are not the same. The atoms of every element is different. And he said in very new and very good way. Until now, no one said that the atoms of all kinds of elements are different. What did everyone say? That, bhai, you keep breaking the particles, the small particles is the atom. He said for the first time that every different elements are different types of atom. And atoms of given elements are identical in mass and chemical properties. That means if I break down the iron rod and take out small atoms, all those atoms will be identical. The mass of all these atoms will be the same. The chemistry properties of all these atoms will be same. Are you understanding this? That suppose if I took carbon atoms and I took oxygen atoms, will both of them be the same? They will be different. That is, every element has its own type of atoms. And atoms of given element are identical in mass. That means if I look at 4-5 crore atoms of iron, the mass will be same. The chemical properties will be the same. Similarly, suppose I look at thousands of atoms of carbon, the mass of all them will be the same. The chemical properties will be the same. Their size will be the same. Okay. This got slightly mistaken. I'll tell you later. A problem came up in this one later. Okay. Atoms of different elements have different masses and chemical properties. He said that same point in another way, that if you take atoms of different elements, the mass of all those atoms will be different. Suppose I have one atom of carbon like this. Suppose it's pink colored. And I have one atom of, suppose, iron. So will both of this atom look the same? No, they will be different. One atom will be big, one atom will be small, one be heavy, one be light. The chemical property of one be something else, as another one be something else. So atoms of different elements have different masses and different chemical properties. Next, atoms combined in a small ratio of whole numbers to form compounds. This is shining a little less. What are they saying? Atoms of combined in the ratio of small whole numbers to form compounds. Let's try to understand. Suppose I took one carbon atom and one oxygen atom, and let's combine this two. What is formed? Carbon dioxide. In carbon dioxide, there is one carbon, two oxygen. So atoms combined in the ratio of small whole numbers, small whole numbers, small 1, 2, 3, 4, 5, 6. They combined in the ratio of small whole numbers to form a compound. What else should we take? Ammonia, right? I took the example of ammonia. Nitrogen and hydrogen combined to form ammonia. The formula of ammonia is NH3. That is 1 nitrogen and 3 hydrogen. Now look at it. What is saying? Atoms combined in the ratio of small whole numbers. Here nitrogen and hydrogen. Small whole numbers ratio. 1:3 ratio to form a compound. You can take the example of water too. What do we get from hydrogen plus oxygen? H2 and oxygen is how much? 1 small whole numbers. They are small whole numbers 2 and 1 in the ratio of small whole numbers to form a compound. Last, the relative number and kinds of atoms are constant in a given compound. what? The relative numbers and kinds of atom are constant in a given compound. What is he explaining? Law of constant proportion. He's saying that the relative numbers and the kind of atoms, what kind of different kinds of atoms will be there, are constant in a given compound. For example, suppose it's water, then H2O1. Should write like this 1, but I write it. So what is the relative number? 2 and 1. And kinds of atom, what kind of atom are here? 2 hydrogen atoms and 1 oxygen. Kind of atom are here, core constant in a given compound. What do we get from here? Law of definite proportion and law of constant proportion. This also we explained. So these were some assumptions or some postulates of our Dalton Sahab. You will have to remember this. Okay? Especially remember these two, because laws are being explained from here. They ask from exam. Were all these statements 100% correct? No, beta. Whatever we know about the universe today, we won't be 100% correct. Either further discoveries will be happening. So later when science made discoveries, the scientist says that, yeah, there are some problems in some points, which we call drawbacks of Dalton's theory. What did we call them? Drawback. Never say failure. Never say failure. Sometimes the book also writes failure. Wrong. NCERT wrote drawback. Very good. Drawback. What shortcomings was there? It's not failure. Let's understand the first thing. Atoms are, meaning he said atoms are indivisible. But today we know that atoms are what? They are divisible. Right? According to Dalton's theory, atoms were indivisible. We cannot divide the atoms. We cannot break the atoms. But now we know an atom is divisible by nuclear reaction, a different kind of reaction. They won't break with chemical reaction. That's truth. An atom is made of electron, proton and neutron, which we will study in the next chapter. What did he know about the future discoveries? This would happen later. The next concept came, isotopes. It's very interesting concept. What did Dalton say? Dalton's atomic theory says that all the atoms of a given element have exactly the same mass. Is that what he said? Look, what he said. Atoms of a given element are identical in mass. That means he said that if I have 3 atoms, if I have hydrogen atom, if I have hydrogens, 3 atoms, hydrogen elements, 3 atoms, what will be the mass of these 3? Will be the same or different? According to Dalton, tell me in the comments. Will be the same, will be the different? Tell me. Same, it will be the same. Dalton said that if there are same elements of different atoms, so their same elements will be identical mass. It happens, it generally happens. But a new thing was discovered, which we called isotopes. What is isotope, beta? Look-alikes of elements. Look-alikes of same element. There will be slight changes. For example, hydrogen was found to have different 3 atoms. There are millions and billions, trillions of atoms of hydrogen. So we saw that there will be 3 different lookalikes of hydrogen. First we call it protium, second we call deuterium, third we say tritium. Protium, deuterium, tritium. Don't memorize this in the syllabus. Their mass, beta, is different. 3 different types of atoms of hydrogen were found in the same element. 3 different ones. 1 small hydrogen atoms was found, 1 bigger was found, even bigger one found. That means these 3 atoms are not identical. So Dalton Sahab was slightly wrong. Such elements that have atoms with different masses, we call this phenomenon isotopes. What is it called? It's called isotopes. Dalton's atomic theory says that all atoms of a given element have exactly the same mass. But now we know that atoms of different element can have slightly different masses. And we call this phenomenon isotopes, hydrogens lookalikes. One hydrogen is this, one hydrogen is this, one hydrogen is this. Its mass is 1, this mass is 2, this mass is 3. Right? This is double its mass, this is triple its mass. So 3 atoms with different masses were found of hydrogen. Another thing we called it isobars. What are isobars, beta? Dalton said that if there are 2 different elements, the mass of their atoms will be different. Did he say that or not? This is what he said. Atoms of different elements have different masses. Yes or no? That the atoms of 2 different elements, that will be completely different. Its mass will be different. This is generally the case, but in some places an exception was found. For example, that we saw that we took an atom of potassium and we took an atom of calcium, and we saw that the mass of both of these atoms came out to be same. You must know that argon is a noble gas. We took atom of argon, we saw that mass was equal to the atom of potassium. We saw that its mass was calcium. So these were atoms of different, but their mass ought to be the same. So this phenomenon is called isobars. We call such elements isobars. Dalton's atomic theory said that atoms of different elements have different masses. They should have had different masses. But now we know that even atoms of different elements can have same masses, which we call isobars. It's not like that happens a lot. These things happen less often, but they are happening. These are the drawbacks of Dalton's theory. After this, what did Dalton Saab says that I am going to put some stamp on the atoms. Yeah. What is the world saying so far? The world is saying that matter is made of atoms. I want to say that the world has made many different kind of atoms. They are not the same kind of atoms. The atoms in the iron rod, the atom in the water, and the atom in the air, all these atoms are different. There are different kinds of atoms in the world. So he started putting a stamp on the atom. He started giving symbol to the atom, Dalton's symbol of elements or atoms. He started giving symbols to the elements to the atom. How did he give symbol? He gives symbol like this. He said that hydrogen from today, we will represent hydrogen like this, here, like this. When I write this, this is hydrogen. He said, whenever I write this I inside circle, that means it's iron. Look like this. He said, whenever I write S inside a circle, understand that I'm talking about sulfur. If I write C inside a circle, understand I'm talking about copper, and various other. He made them with a design that he wrote C inside a circle, copper. I wrote S inside, that means silver. Sorry, if I write like this, it's sulfur. Look, you don't want to memorize because it's not relevant now. I told you slightly. These are non-relevant because these are very tough, yeah. Everyone has different designing. Now look, he made mercury ... Who will make such design? People don't have much time. So in today's world, all these symbols, they stopped using them. Sorry, Dalton Saab, you must have felt very sorry. We have made so much effort, so designed, it got rejected. Okay, Dalton was first scientist to use the symbol. For the first time, someone uses the symbol. That was very big deal. Until now, people thought it was made of atoms only. He said, no, there are different kind of atoms. I'm putting stamp on them. Look, I'm making different kind of designs. How did the initial name was happen? Based on discoveries of location. That bhai, whatever the thing was found, a name was put on that. For example, copper discovery found in Cyprus. Cyprus in island, beta. So it was found in Cyprus and its name became copper from Cyprus. Based on color. Now, for example, the gold's color is yellow. So yellow is called gold also. So gold's name is gold. Gold from English word meaning yellow. The names were created like this. Dalton's symbol for element were difficult to draw and inconvenient to use. Bhai, who will put so much effort? I was told phosphorus, so I am drawing this phosphorus. So it's very effortful. So later this was rejected, and after this, best scientists of the world came over and they made a team. It was called IUPAC. What was it called? IUPAC. IUPAC. IUPAC, International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry, IUPAC. This is the team that said now the symbols were given. Now the naming that we will do, the entire world will use this. Otherwise, by America would understand the copper another way. India will be understand the copper another way. Everyone's stories will be different. So they had to make a common platform. They had to make a dictionary of elements. Who made it? The International Union of Pure and Applied Chemistry prepared a dictionary. And this is now accepted over the world. They said, how will we do the naming of atoms or the name of elements? They adopted 2-3 methods. They also don't have fixed method name. What's in the name? Now, for example, your name is Abhishek. Why? Because dad liked it. Now, suppose your name was kept Ritik. Why? Because that time Ritik Roshan's movies was released at that time. He was a big star. Mom liked Ritik. Mom used to like him. Your name was Ritik. So, bhai, there is no reason behind name. It was name had been kept. We have to memorize it. So, some methods were adopted. The first method was that to write the first letter of the element's name in capital. For example, hydrogen symbol becomes H. Hydrogen symbol H, the capital letter, first letter. Oxygen symbol become O, the first letter in capitals. Carbon symbol becomes C, the first letter in capital. Phosphorus became P. There are many like this, beta. How many should I tell you? You were to memorize this slowly. Phosphorus P, and so on and so on. The second method is that to take the first letter in capital and second in small. These name also started appearing. For example, aluminium, capital A and small l, Al. Calcium to capital C and small a, Ca. Helium, capital H and small a, he was formed. What was the third method? The first letter of element's name, first letter was in capital, and the second, take any letter. It was no fixed method. For example, zinc. First Z, then N was taken from Zn, zinc, Zn. Magnesium, M was taken from here, G from here, M capital small g. Chlorine, C was taken from here, L from here, C capital small l. So names of different elements are formed like this in different ways. Taken from Latin, German and Greek. Someone's Latin name was taken, someone's Greek name was taken, someone's Greek name was taken, German was taken. For example, iron's name was ferrum, so its symbol became capital F small e. Sodium's name natrium, so capital N small a. Potassium's name is kalium, so capital K small a. Capital K was taken, so what is one? K. So there is not fixed method, beta. The name was given, now memorize it. Yeah, now look, these are the short forms. Now what's your short name? You can be anything. Anything, man. I have a friend, Tushar, they call them Gattu Gattu. There is no reason why they call them Gattu. They are just saying, they've been saying this from childhood. So this is how we have a friend, there was no name, we have called them Chena Chena. Now there is no Chena anywhere in his name, but everyone calls it Chena. You must have kept weird names for a friend, you can't say it. What kind of name you gave for friends that you cannot say in the gatherings? So beta, there isn't any logic to naming. It's there has been kept. Now understand this. Now here I bought the first 20 elements. First 20 means there is a periodic table. It's been removed from your syllabus. The names of the first 20 elements inside that were written. So we must not remember their name and symbol. Slowly you will remember them. Don't take pressure over this. All this will be memorized with practice. Still I am writing this. Let's write once. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. You have to memorize only this. I am telling you the name of a mnemonic for memorizing this. If you are needing mnemonic for this and later in chemistry, Ram Nam Satya hoga bhai. Still I am telling you. So what is the mnemonic? Hi, hello, little, bole, bachcho. Hi, hello, little, bole, bachcho. C means seeing C. See Netflix on Friday night. On Friday night. Now you can remember from this. Hi come from hydrogen. Hello came from helium. What came from little lithium? What came from bhole beryllium? What came from bachcho boron? What came from C carbon? What came from Netflix nitrogen? What came from on O oxygen? What came from Friday F fluorine? What came from night neon? So we have to remember this. Hi, hello, little bhole bachcho. See Netflix on Friday night and watch it on Friday night. Bhai, you can skip school even on Saturday. Okay. After that, we have some more next 10 elements. How we remember this? Na mango sona chandi. Na mango Aladdin से ना मांगो अलादीन से पेप्सी, सोडा, कोला और काजू कतली. Okay, so you can remember this. So what not to ask from Aladdin? We should not ask Pepsi, soda, cola or kaju katli. Look from here. Nas from Na, sodium came. Mg from mango, magnesium came. From na mango, Aladdin se Al came. Silicon from se. Pepsi from P, phosphorus came. From soda, sulfur came. From cola, Cl, chlorine came. From or argon came. Kaju, K from potassium came. From that, from Ca from of katli, calcium came. So you should remember these 20 elements with symbols. Pause once and memorize this. With slow will practice will remember this. Will make you memorize this. Don't take tension. Come on, let's move forward. Some other elements with symbols. There are some other elements should be memorized with the symbols. Look, you must have memorized all this. I will tell you barium, bromine is important. Remember this. We have covered all the other things from carbon and everything. Aluminium, boron, calcium, carbon, chlorine. You have covered all this. Remember copper beta. It wasn't in the first 20. Remember fluorine. Remember gold. Remember hydrogen. Remember iron. Remember magnesium, Mg. Nitrogen N, oxygen O, potassium K, silver Ag, sodium Na, sulfur S, zinc Zn. So there are some elements whose symbols you should memorize. You will see them a lot later. So look at this once. Well, we take this. You have to remember those, bhai. Come on, bhai. Let's move forward. Now the topic is molecules. You understand up to more atom. What was the definition of atom? The smallest fundamental particle of matter which may or may not exist independent. Generally, beta, an atom does not remain alone. There are very few elements whose atoms are found alone. Generally, they are found in a group And when they are found in a group, we call them molecules. That's what's written here. Atoms of only few elements exist independently. There are very few elements whose atom remains alone. Atoms of noble gases like neon, argon, krypton, helium, however, what are found. Like helium you just studied. You studied neon, you studied argon, krypton, xelium. There are many other. There are noble gases. Can these remain alone? For example, you took the helium atom and can live alone. It doesn't need to form a group. It can stay alone like this, neon 2, argon 2. So these noble gases are very stable. They are like saint, man. We don't have to get married to anyone. We will live a saintly life. We will remain alone. But there are very such saints in this world. There are few elements in this world which atoms stay alone. Generally, atoms are in group. Okay. Atoms of most elements do not exist independently. The atoms of most elements do not remain alone. They are in groups. And when they are in groups, we call the molecule. Molecule, two or more atoms of same or different kind combine to form a molecule. There will be of two atoms, there will be a same kind, or they may be of different kind. They can be of different kind too. They combine what was formed, molecules. They can be 2, they can be 4, they can be 2, there can be 3, there can be 4, they can be of same kind, they can be of different kind too. Anything can happen. They can be anything. Okay, anything can happen. Just 2 or more atoms coming together, we can call it molecules. Maybe the atoms are same, maybe they're different atoms. Okay, what is the example? Like hydrogen. Hydrogen, beta, you will never find it alone. No two atoms of hydrogen will always move by sticking together like H. That's why you must have seen H2 as hydrogen. Why? Because they are two atoms are always together. Two atoms of oxygen always stick together. O and O are always stick together. They will never be separate. That's why you have seen oxygen written as what? O2, because two atoms are together. That's why it's O2. That is oxygen molecules. What is H2? It is a hydrogen molecule. Similarly, H2's second molecule of hydrogen. Similarly, the second of hydrogen. That means inside the air, when you see hydrogen, you will see what hydrogen? You will be not getting the hydrogen atom. You will get hydrogen molecules. Two atoms of hydrogen stuck together like this. You will find it only this. Hydrogen doesn't keep single atom at all. If you want oxygen, you need oxygen. You look inside and open it and search oxygen. You will see the particles of oxygen. You will not find single oxygen atom. What will they be? There will be two atoms stuck together. There will be two atoms stuck together. Two atoms stuck together. The means that oxygen is made of what? The oxygen gas is made of what? They are made of molecules. The air in the oxygen is what? There are two oxygen atoms are stuck together. Okay, like water. Now, what is the formula of water? By H2O. Now, bhai, let's see what water is. Two atoms of hydrogen stuck together in one oxygen. So they can be different kind of atom too. They made water, beta, right? They can be of same kind, stick together. They can be of different kind. For example, if we look water, water is not made of atom. Water is made of molecules. When I look inside water, I find water molecules, small ones, OH. Do not exist independently. This H is not found all alone. It's found in a group. Carbon dioxide, what is the formula? CO2. Why CO2 formula? Because you will never find one carbon and oxygen inside it. What do we find? We find one carbon, two oxygen stuck together always like this, one carbon, two oxygen always stuck together. This is what we call, beta, we call molecules. So the atoms of same kind might stuck together. Atoms of different kind might be stick together. We call this phenomenon a molecule. What is a molecule? Two or more atoms of same or different kinds stick together to form a molecule. Okay. Now we can divide a molecule into two types. One where atoms of the same kind of set together, one the atoms of different kind of set together. Okay, so molecules of elements. Beta, what are the elements made of? Elements are made up of those molecules whose atoms are same. Okay, the molecules of an element are made up of same type of atom. The molecules of elements is made of, they are of same kind of atom. Example, hydrogen became H2, one hydrogen, two hydrogen stuck together. Oxygen, O2, one oxygen, one second oxygen stuck together. For example, nitrogen. Nitrogen, what is the symbol? N2, one nitrogen, second nitrogen atom stuck together. So what they are made of? They are made of same type of atom. So the molecules are made up of the same type of atom, belong to what? two elements. Molecules of elements are made up of same type of atom. All the elements you see, hydrogen, oxygen, nitrogen, chlorine, you see, chlorine is also an element, right? It's compound or an element. Chlorine, what is it? Cl2, meaning one chlorine came and stuck to the second chlorine. Okay. Now a term came, atomicity. What is this? How many atoms are sticking together? We call this atomicity. Number of atoms present in one molecule of element. How many atoms are present in one molecule? For example, how many atoms are present in one molecule of hydrogen? What would be the answer? 2. So this we call diatomic. 2 atoms. One molecule of oxygen. This is one molecule, right? This is one molecule. One molecule. One molecule. How many atoms are sticking together in one molecule? 2. So this is become what? Diatomic, meaning there are 2 atoms. So what is atomicity? Number of atom present in one molecule of element. Okay. How many atoms are present in one molecule? Okay. This is 2 atoms of oxygen is 2. So how many atoms are present? 1 and 2. So this is beta diatomic. Hydrogen H2 1 2 diatomic. Nitrogen N2 1 2 diatomic. Chlorine Cl2 1 2 diatomic. Oxygen make another compound. One elemental state, it makes another kind of, it makes ozone layer. You have heard about the UV rays emanated from ozone, formula SO3. That means how many oxygen are there? 3 oxygen stuck together. So how many atomicity is this one? How many atoms are there? 3. So atomicity 3. This is called triatomic. 1 is monoatomic, 2 is diatomic, 3 means triatomic, 4 means tetratomic, 5 means pentatomic. This is how it works. For example, phosphorus. Phosphorus exists for P4. P4, it go like this, 1, 2, 3, 4. This is phosphorus's molecule. This, like a kite. So P4, what is this? Tetra. Tetra means 4. Tetraatomic. Sulfur beta, this is very dangerous. 2 atoms are stick together, S2 is formed. 4 atoms stick together, S4 formed. 6 atoms stick together, S6 formed. 8 atoms stick together, S8 forms. So it is very different kind of molecules it makes. Sometimes only 2 sulfur atoms are stick together, sometimes 4 stick together, sometimes 6 stick together. So this is why we call this polyatomic. Poly means anything can happen. Poly, 2, 3, 4, 5, anything can happen. So it can be diatomic, right? Tetraatomic, it can be hexa. Hexa means 6 atomic. It can be octa. Octa means 8. Octaatomic 2. After this beta, these are noble gas. And what did I tell you about noble gases, beta? These are saints, they are hermits, they live alone, they are noble. They are noble means they don't do it to anyone, they are noble, good people. So argon, neon, helium, these live alone. We took beta, they are single like this. So what are they? Monoatomic. Mono means single. Monoatomic, mono, man is written here, monoatomic or monoatomic, clear? So this is atomicity. Come on. Next is molecules of compound. The molecules of an element were made of the atoms of same kind. The molecules of a compound are made of atoms of 2 different kinds. Example, very simple, water. Now look what is inside water. H2O. 2 hydrogen atoms, 1 oxygen atom. Ammonia, NH3. 1 nitrogen atom, 3 hydrogen atom. Carbon dioxide, CO2, 1 carbon atom, 2 oxygen atom. What are all these things, beta? All these things are compounds. This is what compounds means. What? They are different elements, atoms of different kinds. And elements means atom of the same kind. Now tell me one thing. Tell me one thing. Come on, tell me. Is this an element or a compound? Come on, tell me. Is this an element or a compound? Is this an element or compound? Is this an element or compound? Tell me quickly. Is this an element or compound? Tell me. Is this an element or a compound? And tell me, is this an element or a compound? Tell me, is this an element or a compound? By the molecules are made of what? Same kind of atoms. So what? Element, same kind of atom. Element, same kind of atom. Element, different kind of element. Compound, same kind of atoms. Element, different kind of atoms. Compound, different kind of atoms. Compound, different kinds of atom. Compound. So where there are different kind of atoms, there beta compound is formed. Molecules of compound. Water is made of what? 1 oxygen, 2 hydrogen. Ammonia, 1 nitrogen atom, 3 hydrogen atom. Carbon dioxide, 1 carbon, 2 oxygen. Acha. Now look at one thing we studied earlier. Law of constant proportion must be valid. It absolutely must be. That if compound is formed, the pure compound contains the same element in the same proportion by mass. Remember? So look here, if I took water, so what kind of element is made of water? Hydrogen, oxygen. And what is the ratio of their masses be? 1:8 always. Ammonia is made up of what element? One is nitrogen, another one is hydrogen. What would be the ratio of mass? It should be 14:3 here. What is here? Carbon and oxygen. Do you remember the ratio of mass? 3:8. So these three, you remember them if possible. What is the ratio of their mass? Now ammonia can come from anywhere. What would be the nitrogen and hydrogen's ratio? 14:3 by mass. Atoms of different element combined in fixed proportion to form a molecule. What is it? Law of constant proportion. This is what it was, that atoms of different element combines in fixed proportion. How will they be combined? In fixed proportion by mass. So its mass of ratios 1:8, 14:3 and 3:8. You will learn to calculate it too. Don't worry. Acha. Do you get this point? Come. Let's find the atomicity. Atomicity means number of atoms present in one molecule for sulfuric acid. Now, what is atomicity? I told you, number of atoms present in one molecule. Tell me the atomicity of H2SO4. H2SO4. What do you see it in, bhai? There are 2 hydrogen atoms, 1 sulfur atom, 4 oxygen atom. So what is the total? 2, 1, 3, 4. How many is it? 7. So its atomicity is 7. Atomicity means number of atoms present in one molecule. Al2SO4 whole thrice. Dada re dada, what is this? No take tension, I will teach you all this later too. Chalo. Al2. So I can see 2 aluminum atoms clearly. How many atoms of sulfur are there? See, sulfur here and bracket 3. So that means 3 atoms of sulfur. 4 of oxygen are seen here, 3 outside. So this is multiplied. So how many of atoms of oxygen there? 12 beta. Whenever you see written outside, so there will be 4 atoms of oxygen, 1, 2, 3, 4. And multiplied by 3. 3 is written outside the whole bracket. So 4 3s are 12 it became. How much is it beta? 12, 3, 15 to 17. How many is the atomicity? 17. See the third one beta, ammonium hydroxide, NH4OH. How much would the atomicity be? Now this bhai, you have to comment and tell me. You to write some homework, okay? Chalo, tell me the atomicity. Patak se. P4, tell me the atomicity. H6. What is the atomicity? O2, its atomicity. What is it? Has become tetra. It means 4, tetraatomic. What is it? Hexaatomic. What is this become? Diatomic. If you see 2, then it's di. 1, it's mono. 2 means di. 3 means tri. 4 means tetra. And 5 means penta. And 6 means hexa. H7 means hepta. 8 means octa. All this doesn't come. You catch di and tri. Okay. More it doesn't come from here. You remember di and tri and atomicity A. This one. H2 are 2 diatomic, N2 are 2 diatomic, Cl2 2 diatomic, ozone O3 triatomic, phosphorus P4 tetraatomic, sulfur has lot of possibilities, polyatomic, and noble gases are always alone. It means mono, single, monoatomic. Noble gases are always monoatomic. Yeah. So by molecules of compound we have understood different kind of atoms are there. In fixed proportion we have understood. And molecules of elements you have understood. Yes or no? The molecules of elements, group of atoms, they are made of same kinds of elements. Chalo bhai, these are the things we have understood. Next claim, the atomic mass. Atomic mass, mass of the atom. Yaar, what is the mass of the atom? How big was the atom? Did you remember? Nanometer. It means 1 crore times smaller than ant. 1 crore times small. What is the mass of atom? Can we tell it in kg? In grams? How will you tell? It's too small. So for atom's mass, a new unit was formed. For the mass of atom, a new unit was formed. We call the name of atomic mass unit. The mass was so small that it couldn't be compressed in kg or gram, etc. So small, tiny. If we express it in grams, then the power of 10 to the power minus 24, the high, 10 to the power minus 24. So we said, let's make a new unit, atomic mass unit. Okay. An atom is so small that its mass is generally not measured in grams. It's not measured in grams. A new unit was defined, atomic mass unit. Earlier, its symbol was AMU, and now it's noted with only U. Earlier, it was called AMU. Now we call it U. Now, what is AMU or atomic mass unit? What is it? How to define it? So this is a relative scale. What kind of scale is it? Relative scale. It's a relative scale. We said, let's assume the mass of an atom of hydrogen 1. Use your brain. Listen to it corner. I won't tell you above. Above, I will tell you what written in the books. Here, I will tell you what master teaches. What did we say? Mass of one atom of hydrogen's mass. I said, yeah, this mass. Let's take, what is the hydrogen? You know, it's the smallest atom of all. The smallest atom. Smallest of the first one, we take hydrogen, then helium, then lithium. Smallest of all atom. I said her, its mass is, I suppose, 1. 1 is what? Gram, kg. What is 1? I said 1 U. U means AMU. I said 1 U. Now I have to compare any atom. I will tell comparison of hydrogen. How heavy is it? How light is it? How heavy is it? How light is it? I tell you then someday that oxygen, when I tell you that one atom of oxygen, let me consider nitrogen. If I say you that one mass of atom of nitrogen is 14, then 14 what? 14 U means 14 times heavier than hydrogen. Relative scale was needed to introduce by, because we cannot measure kg or gram, it's so small. So what did we define? We said the smallest, lightest is hydrogen. What should we put its value? Put 1. Now everything will be compared with this, all right? But definition is a little bit different because of the problem with this one is hydrogen. So what is the definition? The mass of one atom of carbon 12 isotope is taken as 12 AMU or 12 U. You will remember this one. All right. We have one atom of carbon, not the regular carbon atom, one lookalike of carbon. I told you like lookalike. So this is carbon's atom, whose carbons, I suppose its mass is 12. 12 AMU. Now, how can be 1 AMU defined? 1 AMU is 112 with the mass of carbon 12 atom. What is carbon 12 atom? An isotope of carbon, a lookalike of carbon, one type of carbon atom. I cannot explain this much unless the concept of mole is introduced. For now, catch it like this. How to catch it? The carbon which is there, our bhai sahab, the carbon bhai sahab, he looks in different forms in the world, looks like different looks, different lookalikes of him are there. Some are small, some are big. I took this carbon from this, which I named C12. Mass of its one atom, I said, it's one atom of its mass, I said 12 U or 12 AMU. Either you say U or AMU, it's same thing. Now I said I have to tell 1 AMU. So what will be 1 AMU? 1/12 of mass of one atom of C12, right? C12 is a particular type of carbon atom whose mass is considered to be 12 AMU. From here, what will be the definition of 1 AMU? 1 AMU is AHG. From there, what will be 1 AMU? 1 AMU is 1/12 of mass of one atom of carbon 12. The same thing is written here. Okay, so you have to remember this one. 1 AMU is 1/12 of mass of carbon 12 atom. So one atomic mass of unit or AMU is defined as 1/12 of mass of one atom of carbon 12 isotope. That isotope of carbon. How small is 1 AMU? How small is 1 AMU is 1.67 into 10 to the power minus 24 gram. 10 to the power minus 24 gram. Very, very small. Whose mass is 1 AMU? Of hydrogen's one atom. How much is the mass of hydrogen? 1.63 into minus 24. So how do we define the power? We said suppose the mass of hydrogen is 1 U. Nitrogen's 12, 14 U. Carbon's 12 U. And thus 1 U unit is formed, AMU or U. And on that basis of this unit, we tell different atoms of different atoms. Atomic mass unit, hydrogen mass is, what is it from today? 1 AMU. For carbon, how much? 12 AMU. For nitrogen, 14. For oxygen, 16. 32 for sulfur. 35.5 for chlorine. These are some common. 23 for sodium. 39 for potassium. 24 for magnesium. 40 for calcium. 60 for zinc. This for iron. Don't remember these two. Remember the rest of the possible as much as you can remember. I will keep you memorizing slowly. Okay, tell me one thing. Mass of one atom of hydrogen is 1 U. So how much is in gram? How much is hydrogen's atom in 1 U? Then how much is the mass 1 U? So how much will be in gram? Look here, I have told you already 1 U is 1.67 into the power minus 24. Now it won't look good if I tell mass like this. 12 U means 12 into 1.67 is too long. So we put unit U. So these things you have to remember. You must remember the hydrogen 1, 12 for carbon, 14 for nitrogen, for oxygen. 16, 32 for sulfur, 35.2 for chlorine, sodium's 23, potassium 39, magnesium 24, magnesium 40. This is much, you have to remember this, or otherwise given an exam. Come on, let's do the question. Molecular mass. Now we have to understand the atomic mass. What is molecular mass? Add all mass of the atoms which are inside the molecule. The molecular mass of a substance is the sum of the atomic mass of all the atom in a molecule of the substance. It is expressed in atomic mass unit or AMU, or you can also tell this U. Let's try this. Let's try some examples. Find the molecular mass of H2. We have to find the molecular mass. Molecular mass means add the mass of all the atoms inside it. Beta, how many atoms are inside this? I see 2 times of hydrogen atoms, 2 hydrogen atoms. What is the mass of one hydrogen atom? 1 U. Generally, it's given in the exam, all these things. You have to memorize them. How much is it? 2:1. How much is the mass? 2 U or 2 MU. Come on, the O2 molecule's mass, what is it? How many atoms are there inside? 2. So 2 times of mass of oxygen atom. What is the mass of the oxygen atom? It's given, don't take tension, 16. It's written here 16. So 2 into 16 became how much, beta? 32 AMU or 32 U. Water. What is inside water? By there is quite a bit inside it. There are 2 hydrogen atoms in this and 1 oxygen atom. So what is the mass of hydrogen atom? 1. How much is oxygen? 16. So 16 and 2, how much is it? 18 AMU. Carbon dioxide. What is this? 1 carbon. And there are 2 oxygen. So 2 into O became how much? The mass of carbon is given there. How much is it? 12. How much is oxygen given? 16. So 32 and 12, how much is it? 44 AMU. CH4, methane gas. Look at this. What is in this? There is 1 carbon and what is it? 4 hydrogen. So 4 into H. How much is it? Look, carbon is given there 12. And how much is hydrogen? 1. So how much is it? 16. This is what we call molecular mass, beta. Now you must have understood. It's very simple. What is the meaning of molecular mass? Molecular mass of a substance is the sum of the atomic masses of all the atoms in the molecules of the substance. Sum of the atomic masses. What is inside these 2 hydrogen atoms? 1 AMU, 1 AMU. Add it up to 2 AMU. Carbon dioxide. This is a molecule. What will be its mass? The mass that comes from adding up the masses of its all. That will be the molecular mass. Molecular mass of a substance is the sum of the atomic masses of all the atoms in the molecule. Which atoms are in this? 1 carbon, 2 oxygen. So 1 carbon, 2 oxygen. Carbons is 12, oxygen is 16. So 2 into 16 and 12 is equal to 44. Clear? Come on. Let's calculate more. C2H6. This is ethane gas. Come on, let's see this. What will be this? 2 times of carbon's mass, 6 times of hydrogen atoms. So 2 into 12 plus 6 into 1. So 2 into 12 is 24 and 6, how much is it? 30 U. Ammonia, NH3. In exam, it can ever be given in the name of ammonia, bhai, right? So what is the ammonia? 1 nitrogen and 3 times of hydrogen. Look, nitrogen is given there 14. And how much is hydrogen? 1. So 14 and 3, how much is it? 17. Look, everything is given. Nitrogen 7. Everything is given. CH3OH, ethyl alcohol. Methyl alcohol, sorry. C1 carbon, 4 hydrogen, not 3. How many hydrogen? 3 plus 1, 4. And 1 oxygen. Come on. Carbons given there, C12, hydrogens 1. Look, oxygen is must be given as 16. 1 is here. 16. How much is it? 12, 4, 16, 16. How much is it? 32. Tell me it will be 32, 12, 4, 16 and 16, 32. Ethylene, C2H2. What is it? There are 2 carbon, 2 hydrogen. Beta, you will do it the calculations now. Does it feel like halwa? 2 into carbon, how much is it? 12. 2 into hydrogen, how much is it? 1. So 12 and 2 become how much? 14 U. Tell me, is it correct? Sorry, that was wrong. 2 into 12, 24. Now don't scold me for the calculation step. 24 and 2 become how much? 26 U will. Put U in all of them. What is the unit? U. Right? 24 and 2, 26. Sulfur molecule S8. What is in it? 8 times the sulfur atoms. Sulfur's atoms given 22. Look, is given as sulfur is 32. So 8 times of 32, how much will it be? 8 2s are 16, 8 6 are 24, 256. 256 U. Hydrochloric acid, this is HCl. How to calculate this one? 36.5. Nitric acid, HNO3. Calculate this in the comments. Do you see yourself? See, nitrogen is given 14, O is 16, hydrogen is 1. So you can calculate it. Come on. Formula unit mass. Nothing is there molecular mass. We use them when the compound of a metal and non-metal are there. Don't be afraid of formula unit in the exam whenever it asks to find the formula unit mass. Just calculate the simple molecular mass and submit that. Don't take tension. We use this when there is a metal and non-metal inside the compound. The formula unit mass of a substance is sum of the atomic masses of all atoms in formula unit of compound. This term is used for compounds which are made of irons. The people who are formed of metals and non-metals use atoms in it. Come on, let's start. Sodium chloride. What is inside this? There is one sodium atom. There is one chlorine's atom. Sodium's mass is given 23. Chlorine's is 35.5. Add them straight away. 23 plus. Chlorine's given here as 35.5. 35.5. Sir, how to memorize? You don't have to memorize it. Whatever you memorize while practicing, we'll find out. How much is it? 58,358,235. 58.5. Next, look at calcium chloride. What is it, this beta? One calcium's atom and 2 times of chlorine atom. Calcium's given there 40. It's given 40. And how much will be the chlorine beta? 2 into 35.5. So this became 71 and 40. 71 and 40. Will it be 111? 70, 40, 110, 111. You will find it like this. Okay, so practice this by. For example, I will calculate this in potassium carbonate K2CO3. So 2 times of potassiums, 1 carbons and 3 times of oxygens. Potassiums must have given 39. Sometimes it's 40. So check carefully what is given. So 2 times of 39 plus carbons became how much? 12 plus 3 times of oxygens become how much? 16. So whatever it is, we'll find it. You will do it by. It's very good. Our next topic is ions. Now, what are ions? Suppose I have one atom. Let's assume sodium's atom. How do we write sodium beta? Na for sodium. Suppose I write plus on top of it. Positive charge. Then it will become an ion. So, if a charge comes on top of an atom, what does it become? Ion. For example, suppose I have chlorine. Cl. Chlorine. A minus comes on it. So, that means what came on it? Negative charge. If a negative charge came, this becomes what? Ion. For example, suppose I have oxygen's atom. A2 charge comes on it. 2 negative charges comes. If charge comes on top of an atom, what it become? An ion is formed. Suppose I have magnesium atom, Mg. 2 positive charges come on it. Then also it becomes ion. So atom or group of atom with an electric charge. Now why does electric charge come? I told you, right? Inside the atom, there is an electron, a proton, a neutron. There are many things inside the atom too. If one atom loses an electron, if electron goes out of it, then a positive charge comes on it. What comes? Positive charge. And if the atom gains an electron, eats an electron from outside, then what comes on top of the atom beta? Negative charge. So this is what's written. Atom or group of atom with an electric charge due to loss or gain of electron is called ion. So what is an ion? There is a charge on top of an atom. It can be positive, it can be negative. Okay. Now if a positive charge comes on top of it, then we call it cation. And if a negative charge comes on it, we call it anion. Memorize it like this. Cat has the paws. What does a cat have? Paws. Cat has the paws. Cation has positive charge. So what is cation? Atom or group of atom with a positive charge. What examples we have to remember? Sodium's ion Na with a plus charge. Potassium's ion K also with a plus charge. Calcium's ion Ca with a 2 plus charge. Magnesium's ion Mg with 2 plus. Now sir, how will I remember where 1 plus, where 2 plus, where is minus? You must have to memorize it. There is no other method. You will learn slowly with the practice. The more you practice, the more you remember. But once I will make you pause the video and memorize it now, only then you will start making chemical formula yourself later. And if you don't do this beta, you will cry so much in 10th grade. You won't be able to make any compound or write any reaction in 10th grade. And reactions are abundant in 10th grade. So doing this is very important. What is an anion? Such an atom that has negative charge on it like this. This atom of group of atom with negative charge. For example, chlorides anion Cl minus. Oxides anion oxygen with 2 minus. Sulfate. Now beta, what is this? This is group of atom. It says SO4, right? Atom or group of atom. Generally beta 2 minus comes on it. So what is it? Sulfates anion. Nitrate. What is it? This is also group of atom NO3. A1 minus comes on it. So what did it become? Nitrates anion. I know this feels very new, but you will have to memorize it. We will see this in chemistry. So we memorize it. Now, ions are also of two types. One is monoatomic ion. What is mono means? Single. Whenever mono is written, it means single. Di means two. Tri means three. Tetra means four. So, ions with a single atom, for example, what you take? Na, only one atom with plus charge. K plus potassium ion, one atom with a charge on it. Cl minus, one atom with charge on it. Oxide, one atom with a charge on it. Okay. And the second is polyatomic ion. This can be asked in the exam. This one is not. This is a question in NCERT. It's also questions in the back exercise of NCERT. The polyatomic ions give and their examples. What is polyatomic? Poly means more than once. Poly means more than once. So suppose there are one or more than one atom. For example, you can see this one. Ammonium cation. NH4. 5 atoms and 1 plus charge above it. Like hydroxide anion. 2 atoms and negative charge above it. Like you have saw this nitrate anion, 4 atoms and negative charge above it. Carbonates anion, this is towards CO3, 4 atoms and above it 2 negative charge. Or sulfate, 5 atoms and above it 2 negative charge. So if there is a group of atoms, if there is charge on it, then we call it polyatomic ion. So these were some of your common ions which you must remember and you have to remember. And with this, I will able to teach you the concept of valency. What is valency, beta? Valency is that we have how many hands? How many hands do human beings have? Generally, there are 2, and if we know is happening in life, okay? How many hands do octopus have? They have 8 hands, and lion has 4, combining all. So some elements have how many hands? So we call it valency. The more hands I would have, the more I would be able to connect with people. If I have 2 hands, then I can hold 2 people's hand, one from here, one from this side. In life, by the way, hold 1 person's hand, not 2. You'll be very bad. So I can hold 2 people's hand. This is my combining capacity. What is my combining capacity? 2. At a time, I can hold 2 people's hand and combine them. Octopus combining capacity, it has 8 hands. It can shake hand with 8 people at once. It won't shake hand, it will hold it. So this is what we call valency. The combining capacity of an element is called its valency. The valency of an element can be thought of as the hands of that atom. How many hands are there in that atom? Come on, I will do it and show you. For example, leave this line. For example, valency of magnesium is 2 and valency of chlorine is 1. Learn it like this. You just saw what was written on magnesium. 2 plus was written. What did we write on chlorine? Minus we have written. Look here, written minus here. Magnesium has 2 plus and chlorine minus. This is beta. You will find valency. If you remember this one, you will remember the valency. It means the valency of magnesium is 2. It means how many hands does magnesium have? It has 2 hands. So suppose here is magnesium. How many hands does it have? 2, 1, 2. What is the second? Chlorine. Chlorine, there is 1 negative charge. It means this has 1 hand. Now forget the positive negative. Whatever is written above, that many hands it has. 1 negative means 1 hand. So how many hands does chlorine have? It has 1 hand. Now tell me, how many hands of chlorine will magnesium hold? From this side, magnesium will hold 1 hand of chlorine. And from here to magnesium will hold second chlorine's hand. So the compound of magnesium and chlorine would form together. What will be get? It will be formed MgCl2. Look like this, beta. The compounds are formed. I will teach you the easier way right now. I'm teaching valency right now. Valency is the combining capacity of an element. That how much I can combine. How we think of it? It can be thought of as hands of the elements. See the second one. Valency of carbon is 4 and valency of chlorine is 1. If I write carbon beta and carbon's valency beta, actually it's wrong to say plus 4. But still we consider 4. Actually it was away from plus 4 and minus 4 concept. And chlorine's valency is minus 1. It would be wrong to write it like this actually, but still, chalo, I will write it like this. Writing plus minus, it is incorrect little bit. But anyway, chalo, carbon's valency is 4 and chlorine's valency is 1. So how many hands does carbon have? 4. 1, 2, 3, 4. And how many hands does chlorine have? 1. So how many hands of chlorine will carbon hold? From here 1 chlorine's and from here second chlorine's and here third chlorine, from here 4th. It means carbon and chlorine combine better the compound that we formed. It will be C and 4 chlorine, Cl4 carbon tetrachloride acid is formed. So this way you can make any compound in the world. Just like if I take sodium and oxygen. Sodium and oxygen. What is the charge on sodium? Let's see a little from here. Plus, and oxygen has 2 minus. So of sodium on top of it, plus 1 and oxygen 2 minus. How many hands does the sodium have? 1. So I made 1 hand of sodium. How many hands does the oxygen have? 2. So I made 2 hands of oxygen. 1 oxygen will combine with how many sodium? With 2. It would hold one hand from sodium from here and one from here. What compound would be formed combining both of them? Na2O. 2 Na and 1 O. This is called valency, but in exam we don't make compounds like this. Don't worry, there are easier ways. Na2O. Now generally you see like this, we write metal first and we write non-metal later. Now sir, what is metal and non-metal? You have seen a little bit in the previous chapter. I'll teach you more here. Now see names, valency and symbols of some ions. Beta, you will have to remember this. What did you do, master? Everyone in this world memorized it. Whoever has not memorized it, his chemistry got destroyed. So swear to you. One thing, the comments are here. Whom all swear to your parents, swear on the exams, 100%, even 98%, otherwise we fail in exam. Similarly, there is swear upon you. It's serious swear, you memorize it. Sodium, potassium, silver, copper. On these three, one of these four plus one. Sodium, potassium, please remember. Copper, they write in exam, because copper, sometimes there is plus one, sometimes there is plus two. It's written here. So copper 1 or copper 2 will be written. All the metals, beta, you will see potassium, silver, copper, magnesium or calcium, zinc, iron, aluminium, all the metals you see, all get a positive charge. All positive charge. All of them becomes cation. On metal, there is always a positive generally, okay? See the second one, the two valency ones which have plus 2 charge. On magnesium 2 plus, on calcium 2 plus. Remember this, on zinc 2 plus. It tells you irons because irons also has two valencies. One is 2 plus, one is 3 plus 2. See, copper also have 2. So remember this, magnesium, calcium, sodium, potassium. Then see aluminium. This one is 3 plus. This means the valency of this is 3. This 3 hands. Iron have 3. It can also have 2. We have to remember this. Then see non-metals. Non-metals have negative ions. That means they are anions. Hydrogen in one special exception, because hydrogen is neither metal nor non-metal. It has a lot of controversy. There is a lot of fights on hydrogen, metal or non-metal. Hydrogen shows both of these. Hydrogen shows H plus also. There is found H minus also. This is more common, H plus. This is less hydride. Then chloride, Cl. Bromine minus of Br, iodide, it's obvious to remember it. Oxide, you should remember 2 minus. Sulfide, to remember 2 minus. And there is 3 valency anion, 2 negative charge, nitride and 3 minus. Now see some combinations of atom 2 which we call polyatomic ion. These are very common. Ammonium, NH4 plus. Hydroxide, OH minus. Nitrate, NO3 minus. Hydrogen carbonate, or it's also called bicarbonate. HCO3 minus, carbonate CO3 2 minus, sulfide is asked less, SO3 2 minus, sulfate is often asked, SO4 2 minus, phosphate is also asked less, PO4 3 minus. So these all cations and anions you will have to remember, and they are not important ones, bhai sahab. So you have to remember this months, all these will come. Practicing you will learn it too. I write it on every page. Chalo bhai. Now you have to write compounds. Sometimes it's written in exam hydrogen chloride. What is hydrogen chloride? Can't understand. How do we write? What would be? Come, let's see the method of writing hydrogen. So the first I have written here H. Chloride means chlorine. So I've written Cl. Now I should know their charge. Chalo beta. What is on hydrogen, beta? Generally it's positive. The negative ones, there is a very less charge. There is positive. So hydrogen, fine. This is, what is it? H plus. Can you see it? Can you see it? You can see it clearly, H plus. On hydrogen, it is H plus. And on chlorine, there is 1 minus, Cl minus. So write it by here, whatever you see, write it clearly. H is 1 chlorine, Cl 1 minus. 1 above, 1 above. What you have to do? It's written here. We have to bring it here. So what is written here? We have to bring it down here. Cross multiply. You didn't have to see the charge. You have to see the number. What is the number here? Plus 1 and here minus 1. So below H came 1 and below Cl also 1, negative, positive, forget it. It's simple. What am I saying? Forget the negative, positive. Listen to me carefully. Forget the negative, positive. Only see the numbers which is written here. That number you have to join boy. HCl on H plus 1, Cl minus 1. This plus will come here and this minus will come here. It means 1. This one went here, this one went here. So H also 1, Cl also 1. Formula is HCl, hydrochloric acid or hydrogen chloride gas. It would be both. Hydrogen sulfide. Beta, hydrogen H. For sulfide, we will write sulfur S. Now their valency, actually, you have to memorize it. Find it here, find it. hydrogen be +1, sulfur would be -2. It's here, sulfide. Can you see it? -2. Acha. Don't take tension, don't take tension. 2 minus, this one, write it like this, 2 minus. Forget the positive, negative, bring it here, bring it here. What came below H2? What came below sulfur? 1. What will become? Hydrogen sulfide H2S. Any chemical formula, you can write it now. Magnesium chloride beta. NCERT tells us, write this, like the valency. This is the easiest way, NCERT. Magnesium, Mg. Chloride means Cl. Now see, on magnesium, there will be 2 plus. Find it, find it, find it. Here it is 2 plus. Okay. There would be 1 minus on chlorine. This one 1 minus. Okay. Now cross multiply. Forget the charge, the number across cross multiply it. It will come here, it will come here. Below magnesium, what did it came from here? What did it written here? 1. Then came below chlorine, what is it? 2. Then what did it become? MgCl2. Aluminium oxide. For aluminium, we will write Al. For oxide, we will write oxygen beta. See the valency of aluminium +3. Do you see it? So I'm right here 3 plus. Oxygen's valency you have seen 2 minus. I mean charge is 2 minus, valency is 2. Remove the charge, so valency half. Now see cross multiply. Forget the positive negative. This 3 will come here, this 2 will come here. So it will become Al2O3 aluminum oxide. Even if you ask a senior aluminum oxide formula, he can't tell you because they probably don't read it. Here, let's move ahead. Calcium oxide. Now see, a special thing is going to happen. Calcium Ca, oxide O. Calcium charge you will see only 2 plus. It's here. 2 plus. This is why I've written it. You should memorize this slowly. And oxygen you will see 2 minus. It's here. When is beta equal on both sides? Dui. Then cut it. 3, cut it. 4, cut it. If you find equal, then cancel it. If you find equal, then cancel it and write directly whatever it is. CaO, calcium oxide. If you find it equal, then calcium. Sodium nitrate, sodium beta, Na. Nitrate beta, you have to find it NO3 minus. Where is it? It's here. NO3 minus. Can you see? Chalo. NO3 minus. What you have to do on sodium? There will be +1. Both 1, 1. You will cross multiply 1, 1. Nothing will happen. The same thing was written. NaNO3. Calcium hydroxide. This one is special. Carefully. Calcium Ca hydroxide OH minus A. This one. Hydroxide OH minus. You should remember all this. On calcium 2 plus would come A. This one. 2 plus. Okay. Now we will cross multiply it, but carefully. This OH is one full ion. It's one full ion. So this 2 will go on OH and this 1 will come on Ca. Here it is 1 on Ca, 1 has come. 2 will come on whole OH. So here we will bracket, we'll make it like this. Why? Because both of them will get the 2. Bhai, both of them came together to play this game. What is there in hydroxide? Whenever you find a polyatomic ion, whenever you find 2 atoms ion, this whole cross multiply game, on what would this cross multiply go? It would go on both CaOH whole twice. Sodium carbonate. Na. Carbonate, you will see CO3 2 minus. Here it is. CO3 2 minus. You will have to memorize this by slowly. Now see, this plus will go here, this 2 will come here. So what is under sodium? 2. And what came under CO3? 1. No positive, negative. It's mean like this. 1 will go from here. 2 will come below this. Na2CO3 sodium carbonate. So like this, beta, you can practice. There is so much. Ammonium sulfate. Ammonium beta, find it. NH4 plus. Did you find it? It's written here on the side. This must be here. Yeah, this one. NH4 plus. Sulfate. SO4 2 minus. You haven't memorized it. Pause it and memorize it. Then practice. May God, the girl that you like or the boy that you like ends up liking someone else if you don't memorize it. Curse of the master. And if you memorize this formula, you memorize even my time. Now you will pause and memorize it by bhai. Look here, there is 1, here is 2. Now this 2 will come on what? On both of this beta. What is ammonium? It's polyatomic ion. So on both of these, this will come 2 on this means NH4. On the whole of this will come 2. SO4. Tell me, is it correct? On SO4 only 1 coming. There is 1 is written. So the whole is 1. So ammonium sulfate NH4 plus SO4 2 minus. On what this 2 will come? It would come on this whole ion. On this whole ion. NH4 whole twice. And what came here? 1 came. Magnesium hydroxide. Magnesium Mg2 plus hydroxide OH minus. You will cross multiply. Now tell me, where will this 2 go? This whole it will go on this hydroxide and under Mg 1 came, 1 is not written. And OH 2. Sodium oxide, sodium beta Na plus 1 oxide O2 minus, cross multiply 1 here, 2 here. Below came 2 and here is 1. Na2. Aluminum chloride. Aluminum you will see 3 plus. Chloride you will see Cl minus. You will cross multiply below Al, 1 will come and Cl, 3 will come. So do in the speed. This one you will do as a homework. This one will do as a homework. This one I will do. Copper to bromide. Copper Cu. When there is 2 written in the bracket, then 2 plus you will have to write. If 1 is written, then 1 plus you have to write. Bromide. Bromide beta, if you see it's Br, there's a minus on Br. Where is bromide? Here it is. Br minus is written here. Bromide, Br minus, okay? So what would become beta? 2 went here. Under Cu came 1, Br, 2. Copper bromide. Zinc phosphate. Zinc beta, Zn. Phosphate, you will check PO4 3 minus. You will have to remember this one. PO4 3 minus. 3 will come here. So under zinc there will be 3 and PO4 what will come here? 1 will come. So 1, there is no bracket, you have to write for 1. 1 came. So 1 remained. So what's the meaning of making bracket and writing 1? There is no meaning. So simple. Zn3 PO4 zinc phosphate. Okay. In this all the questions from the best set of the NCERT are covered. Magnesium hydrogen carbonate. Magnesium Mg2 plus. Hydrogen carbonate you will see HCO3 minus 1. Where is it? Hydrogen carbonate written in L1. Hey bhaiya, given the PPT to type HCO3 minus 1, magnesium hydrogen carbonate. HCO3 and a minus on the whole of this. There is minus on the whole beta. So this is 2 will come on this and will come on this. So magnesium came 1 and HCO3, what came on the whole of it? 2. Then beta, this is called bicarbonate. If they write bicarbonate in the exam, bicarbonate. So what is bicarbonate? Hydrogen carbonate. Aluminum nitrate you will do. Baking powder. Baking powder, the NCERT asked the question. Actually, what happens? Sodium hydrogen carbonate or sodium bicarbonate. What is sodium? Na plus 1. Hydrogen carbonate, HCO3 minus 1. Both sides there is 1, 1. That means write it NaHCO3. So you can write like this. Quicklime. Quicklime is beta calcium oxide. So you will make it CaO. Iron 2 sulfate. Iron we use Fe. 2 is written in 2 plus sulfate SO4 2 minus. See iron 2. Iron we use Fe. Fe. It must be here. Iron 2 is not given. This one iron 2 Fe2 plus sulfate SO4 2 minus. So 2 would become the same. So it will be cancelled. Simple FeSO4. Ferrous sulfate is made. Iron third oxide. So iron third is written. So 3 plus whatever is written next to iron, put that oxide O2 minus, cross multiply Fe2O3. So this is how beta you can make it. Okay? What is the question? Write down the names of the compound represented by the following formula. You have to write their names. What is the first? Aluminum sulfate. Second, calcium chloride. Third, potassium sulfate. Fourth, potassium nitrate. Fifth, calcium carbonate. So you write it. This is your homework, bhai. You complete it. I have told you aluminum sulfate, calcium chloride, potassium sulfate, potassium nitrate, and calcium carbonate. Potassium is nitrate, I'm saying, not nitrite. Okay, this is 2 NCERT's question. How many atoms are present in the H2S molecule? How many atoms are present in here? 2 are hydrogen and 1 of sulfur. How many are there? 3 atoms. Phosphate iron. How many atoms are there? 1 can see 1 phosphorus atom and 4 oxygen atom. How many are they? 5 atoms. This is the atomicity. Here, beta, all these questions and this chapter gets over. Now I do the announcement of the winners of the last lecture. So, bhai, who are all the winners of our last lecture of tissues? Samarth 9354, Uzaib Ali, Mr. Shivam Cyber 03, Gursagar Deep Singh Chauhan, Divyanshi Singh, Rudra Jha, Cricket with Ritik, Vibhuti Ambedkar, Mohammad Kazim, Khushi, Awesome World, Vikshan, Vinayak Tiwari, Shaurya Garg. All of them are winners of the many more. Bhai, everyone is a winner who commented right. Whoever will comment on this lecture too, I will announce the names of those winners in the next lecture. Well, it feels great to teach you. I'm traveling a little during this time. There are a lot of tasks of the company, but still I'm shooting the lectures in whichever city I'm going. I'm taking out time. Keep studying. If you like it, lecture, then say, sir, we enjoyed it. All the very best.